Pretty good. All right, so we didn't coordinate. So I'm going to give a completely personal view of what I think I've learned and what I think is what I've missed this week. So what do I think I've learned this week? On the assimilation front, the first point is rather a depressing idea for a university-based modeler. I think for assimilation at this kind of scale, we're moving beyond the kind of proof of concept, evangelist, lone wolf kind of modelers that show that yes, this could be done and it might be worth doing. And that took a long time. But I'm hearing less and less debate now about whether the idea of conforming a model's behavior to the data that we've got in order to do something with it is a good idea. You still hear it. Ideas like you can't do it, anything you learn here you won't be able to use there, or anything you learn now you won't be able to use later, or something like that, but it's becoming rare. So I think people have decided this is a good idea, and now the big guys have moved in. So this is great, it has to be done. But the task now of moving from a kind of cottage scale assimilation to an industrial scale assimilation, and I think some of the talks this week about the painstaking work of developing the atmospheric corrections and filtering the information through from the radiances that are measured by the satellites through to quantities that the model can actually be confronted with, it's going to be, progress is going to slow, it's going to be hard work from here. And it's going to mean, it's going to have programmatic implications for how the community organises itself to do this. And having left the European community a few years ago, one of the things I noticed is I think Europe is actually particularly good at this. Europe is particularly good at devising projects at the scale that you need to have these industrial level data streams combined with the research strengths to use them. Next point, I saw an astonishing range of new products this week. I'm going to forget most of them next week. That's just the way the brain works. So it's a full-time job keeping up with the range of different products that are turning up now. So I'm going to make a recommendation about that down the line. Third point's already been made a couple of times already, and it's the different mismatches that occur in the different problems. So for short-term applications, the amount of data and the resolution at which that's becoming available is leaving our ability to model it in any computationally affordable way or even intellectually kind of seizable, graspable way behind. We're drowning in data. For the climate problem, where all the interesting stuff happens really slowly, it's a different problem. And the effort on synthesis of long-term data sets and reanalysis, the painstaking blood, sweat and tears of comparing instruments over 30 or 40 years and so on is really slow, and it's absolutely necessary for climate data assimilation because so much of what's important happens on decadal timescales, and individual remote sensing experiments are usually shorter than that. What's new? For me this week, and I saw a whole bunch of new probes of plant physiology. I'd written down during the week, why no talks on fluorescence? So I cancelled that yesterday afternoon. And the idea that broad-scale measurements of PRI, of fluorescence, of water content, all these kinds of probes of how the plants are actually behaving is something, again, that the modelers are going to have to catch up with, but it's data that we know that we need to get in between the drivers and the net fluxes that we've been able to understand for a while. Finding some observations along those chains of assimilation of carbon and the causality is something that we've been crying out for ages. The range of cheap in situ sensors that are becoming available is tremendous. I've already mentioned the growing appreciation of long records, and the amount of effort that I've seen this week on people doing that is fantastic. And there's one other point I was going to make. A partial point. This is a glass half full, glass half empty problem. About half the talks I saw this week on new products mentioned the uncertainty that should be associated with the product. As a data assimilator, if I don't have an uncertainty, in principle, I can't use the product. The The two quantities are exactly as important as each other, so I really commend those people that, along with the development of their processing algorithms, are developing abilities to generate the uncertainties. If you're not doing it, you should. So it could just as easily have happened, just as easily come in this section. What did I miss this week? A reminder, of course, I couldn't see the posters. There's lots of stuff that I probably literally did miss. But a few comments. If we're doing the land, where were the wetlands and the associated products? Was there a poster floating around on long-term monitoring of changes in wetlands? And if not, someone should be doing it. I didn't see much mention of the atmosphere. That's something I was going to notice as an atmospheric guy. But there are a range of products that we can sense in the atmosphere that are good remote sensing tools for biospheric function. The atmospheric CO2, as well as being of interest for its own right, is a pretty good marker of how the ecosystem is behaving. And there are others, things like carbonyl sulfide and so on. How many of these are amenable to remote sensing? That's a different question. But I didn't see much on methane, probably the same comment on the wetlands. And purely from the data assimilation point of view, I'm still waiting for a serious reanalysis of what do we think the terrestrial ecosystem has been doing over the last 30 years, confronted with all the data that we've got. And I've been part of projects that have promised this. I didn't deliver, and I haven't seen it since. A few recommendations. I recommend something really simple. It can come directly out of the talks this week, something to put this together. A web page with a full list of the available products. It can be really incredibly simple. It doesn't need to be advertising. It should just be, this is the name, this is the kind of variables they retrieve, and this is where you go to get more information. And that means that's kind of an hour's work for someone, plus revisiting it once every 3 months or becoming well enough known. Modelers and product providers need to spend more time together. Free beer is the usual solution to that problem. That point's already been made in the previous comment. As I said, Europe's actually pretty good at this, but it could always be better. And it's going to need to be, the integration has to be closer if we're aiming to be able to feed information in a continuous flow from the measurement through to the model. That's going to have to be quite a tight integration. And part of that could be the agencies who are actually producing the products could not just publish kind of an ATBD telling us how they did the mapping between the measurement and the quantity we're interested in, but actually publish the observation operator code. Because with a bit of luck, that can really shorten the time it takes to get these products operationally assimilated into something like this. A couple of final comments that I forgot to write and remembered this morning. I didn't know much about agricultural remote sensing before this week. I knew it existed, but I didn't know much about the history of it. I am hard pressed to think of a cleaner application for the kind of dynamical assimilation into a dynamical model with payoffs in the reasonably near kind of seasonal term. It's hard to think of a nicer application for data assimilation of remote sensing products than doing it on crops, where we've got a measure of crop state. I've not seen it done. This sounds like a really interesting project to write the assimilation into a dynamical crop model with the kind of combination of learning about the underlying physics of the problem and learning about influencing the trajectory of the current state, and the uses for that product seem pretty obvious and pretty direct. I'll stop there. Any other thoughts?
I've got the slides.
Good. I'll step off to the side.
So, just while I'm putting the slides up. Yesterday evening, Matt Disney said, "Oh, by the way, I've told Fred you'll be happy to do my you'll be happy to do my presentation tomorrow morning." I said, "Oh, great. Have you got some slides?" No. So you'll have to forgive me for the brevity of this, but these are some quick thoughts that I threw together. So I think, and this actually, so Peter and I didn't collude on putting these slides together at all, but I think this kind of echoes some of the things that Peter was saying. We're now in a position where most of the land surface models, well, a large number of the land surface models have data assimilation schemes associated with them, which is completely different from 10 years ago. So we had talks and posters doing data assimilation with Jules, Orchidea, Bethy, MPI, and apologies to any of the models I've missed out, but ISPA, JS, Bark, CLM, and so on. And I'm certain that I've missed some out there. But there's a huge amount of activity in this field. And one of the most interesting things that I've noticed happen over the past 5 years or so is many of the techniques that people are using are becoming less and less ad hoc and more starting to use the real formalism of data assimilation, which I think is a really very, very positive thing. And I don't think we can underestimate the contribution of the automatic differentiation software that's now available to this field. I think when you look at most of the big models, they are using the joints in their data assimilation systems that have been produced by those types of software. And that was very apparent at this meeting. So, and there was comment just after the last talk about the need for remote sensors and modelers to work together. And I couldn't agree with that more. To do data assimilation, I think you need a good understanding of your model, a good understanding of your data assimilation technique, and a good understanding of your observations. And what we have in this room is people who are expert in all three of these things. And many people are expert in two of these things. What I don't see a great deal of is projects integrating all three of these aspects that contain experts in all three of these aspects. And I think often the weak point is the use of the remote sensing data, even if I do say so myself. So I think it really is incumbent on this community to make sure that we have an ongoing and continuing dialogue between the modelers, the data assimilation people, and importantly the remote sensing folks to get this working properly. I added some points here about what sort of observations we were using, but I guess rather than reflecting the sessions in general, these kind of reflect my the things that I brought out in my talk. Or perhaps I should say my talks, but you have my word that Jean-Luc's slides were not prepared in conjunction with mine, and we said pretty much the same things. So, ideally, what satellites measure, sorry, forget the ideally part, what satellites measure is the amount of energy leaving the top of the atmosphere. That is the observation that they make. So, ideally, that's what we want to assimilate into our models. But at the moment, that's not a very pragmatic thing to do because it needs extremely complex observation operators, and it's a very ill-posed problem because we don't have sufficient information about the atmosphere to solve the atmospheric correction problem. So pragmatically, we could do something like assimilate observations where that have less processing required to get from the top of atmosphere signal to the thing you're going to assimilate. I'm not going to stand here and say, don't assimilate GPP, don't assimilate LAI, don't assimilate those more highly derived products. But I think it is absolutely incumbent on us to make sure we understand how those products have been derived and whether or not they conflict with our models. So I think what I would conclude with is that whilst I completely agree with Peter that we're now at the age of being early settlers in terms of being land surface data assimilation people, I still think we have some way to go in the proper integration of remote sensing into these models. So what I hope is that this meeting is the start of a long series of discussions about this.
So the suggestion that there be one website where you can get all information on the various products, we did that maybe 5-7 years ago, and we started to maintain it, but there was very little interest from the community, and so we stopped. So there's a website already created which could be updated if there's enough interest. And it wasn't clear to me that there really was, because those, I guess it's the difference between the people that know what they want to use and are using it, and those that really don't know what they want to use and want to know what's out there and what the variables are. But as we get more and more products, generated, I think it's perhaps more important than it was before. So maybe we should revisit that.
Yeah, just to add a comment on that, I think that's a role of the CEO's LPV to compile this list of products with a short description, and even to provide the uncertainties that are attached to the products. So this is really mandatory, and I think that's so Miguel is not here yet, but I think it's well understood by the CEO's LPV and the subgroups.
So we could hand it off to him.
Yes.
Particularly if he's not here.
Okay.
But maybe this should be also part of the geo portal.
Sure. Well, really costly installed.
Maybe just a comment, and can introduce the next part on agriculture. The fact of data assimilation in agriculture has been tried for several times, and it has been there was quite some problems with that at different points. I'm not sure exactly why, but it's an old question that has been addressed for a while, and hopefully will be addressed, because as you say, there's a lot of use for that. But I think part of it was also a lack of understanding of really what we wanted to assimilate in the models and what was actually provided by the remote sensing. And this is not a question only of the processes or the variables, but also of the mismatch. Because in agriculture, a lot of the models in which this was done was crop-specific models developed on trial basis by people who actually are doing trials and see how the model behaves, and then the remote sensing was from coarse, mixed pixels, trying to give something that was not crop-specific and not entirely the same thing.
That could be time for a revisit.
Yeah.
I'm not sure we're reading on some of those problems I think we might have made some advances on.
Yeah, I can make a comment also on that, because we tried that several years ago, not with a lot of success, I must say. And one reason was, let's say, incompatibility between the observations and what the model was trying to describe. So there was so much mismatch between the two that. Okay, so the uncertainties was so large that it bring not too much information to the system. And now more and more people modeling crops growth is trying to incorporate some social description of the crop, which is mandatory if you want to simulate the relative fluxes that you are observing with remote sensing or the type of machines. So that's the way it's going currently, but that's needed. Either too late or too early for the coffee. Let's say it's too early, or so I propose we stop here. Otherwise, we will miss the coffee break. So so we'll convene. So maybe a bit earlier, so to get time. So I propose to come back at let's say 10:35. So in